All right, 7.4, systems of nonlinear equations in two variables. These equations now, some of them are linear, some of them might be a parabola, some might be an ellipse, some might be all kinds of different things. So this is using two equations, whatever form they're in, and solving them. So we might have one solution, we might have multiple solutions, depending on what we're looking at. So on this first one, I have a line, okay, the first one up here is a line because I just see x and y, everything's to the first degree. The second one, it has y to the first degree and x to the second degree. That's what we would call a quadratic, right, which is a parabola. So when you think about what our choices are here for this, if we have a parabola, maybe that line comes through and hits it twice, okay? So if that's the case, we would have two solutions. But maybe we have a parabola and the line comes through and just touches it one time, okay? So we could have one solution. Or perhaps on my parabola, okay, the line is completely off of it and we have zero solutions. So each time you go to do these, you know there's options for how many solutions. So it's not like we can always look and say, this is how many you should get. There are differences depending on how the two equations meet on a graph. So basically when we go to solve these nonlinear systems, you're looking for either substitution method or the book calls it the addition method. I like to call it the elimination method, whatever it's kind of set up for. On this first one, I see that I have a y all by itself already in the second equation, so I think it's set up perfectly for the substitution method. So I'm going to take all this value of y and sub it into the other equation so we can work to solve it. So I have 2x plus x squared plus 6x plus 7 that I'm plugging in for that y, okay, equals that negative 5. Now, my parentheses were only there to kind of show you that that whole group went in there for y, but it's not necessary. I do have a quadratic, so I'm going to put it in highest to lowest degree and join like terms. So I have an x squared plus 8x. And if you're okay with it, I'm going to add 5 to this side. So it's going to be plus 12 equals 0. Okay? That way, I have it set equal to 0. So I'm trying to solve a quadratic. I can graph it to see where it crosses the x-axis. I can complete the square, take the square root, factor it, or quadratic formula. Factors of 12 that add to make 8. I think we can do that. How about x with 6 and 2, and both of them get a positive. All right, that means if x plus 6 equals 0 or x plus 2 equals 0, so x is going to equal negative 6 or x is going to equal negative 2. Okay, so now that we know that we have two x's that would work here, let's plug them in for the y's. I'm going to take the the top equation. 2 times negative 6 plus y equals negative 5. Negative 12 plus y equals negative 5. So y equals, when I add 12 to the other side, y equals 7. So when I plugged in negative 6, I got 7. That's one of my ordered pair solutions. I'll do this again with my second solution. 2 times negative 2 plus y equals negative 5. Negative 4 plus y equals negative 5. Add 4 to the other side, y equals negative 1. So I'm going to get, at negative 2, I get negative 1. So this one had two solutions, so it must have crossed through the parabola twice, okay? All right, let's look at number 2 down here. All right, on number 2, and I'm a little ahead of game as far as maybe you haven't even seen these yet. Both of these equations have an equation of, well, I shouldn't say both. One has an equation that's called an ellipse. Okay, that would be this top one. And an ellipse is kind of an oval-shaped graph. We'll get into this in Chapter 9. And then the second one is actually what we call a hyperbola. Okay. And as far as thinking about what this looks like, so the first one, you have an ellipse and you have a hyperbola. Hyperbola has two curves. You could possibly have a hyperbola that goes like this and then like this, and in that case there are zero solutions, okay? They don't touch. But you could have your ellipse and you could touch just on the ends, okay? So you could have two solutions, right? You could have an ellipse and you could actually cross through it twice, like that. So you could have 4 solutions, okay? You could have a combination of, let's say, one goes through and one hits at the end. So we could have 3 solutions, okay? And, or maybe you just touch one time and the other one doesn't touch, so you could have 1 solution. 4, I think, would be the max we could have. But as you can see, many different ways these could work to know how many solutions we have. So let's do the algebraic method, and that tells us then how many solutions we end up having. All right, to be honest, the way these are set up, it's a little strange, being the constants on the left and stuff, but they're set up perfectly with the x squareds on top of each other, the y squareds on top of each other, the constants on top of each other equals 0. I think for the elimination method. Right now, no x's squared or y squared would cancel, but if I work with my x squareds and try to get them both to the 6's, I think I'm going to take the top equation times 2 and the bottom equation times -3. So the top equation will become 6x squared plus 8y squared minus 32 equals 0. The bottom equation, when I multiply by -3, I'll get -6x squared, positive 9y squared, positive 15 equals 0. All right, add my 2 equations, my x squareds cancel. I get 17y squared minus 17 equals 0. That's a good sign for me. Add 17 to the other side. Divide by 17. And when I take the square root, be really careful here. When I take the square root of 1, I get positive or -1. It's so important that we get both of those values. I'm going to plug them back in to see what I can find. I'm going to be honest, no equation looks beautiful here. I'm going to go with the bottom one because it's a little bit smaller. So 2x squared minus 3, and I'm going to plug in positive 1 squared to start with, equals 0. All right, so 2x squared's not going anywhere. 1 squared is 1 times -3 is -3. Get 2x squared. I'm ahead of my game here, my brain's. Okay, 2x squared minus 8 equals 0, so 2x squared equals 8. X squared equals 4. Take the square root, and I get 2 different answers here, plus or minus 2. So when I plugged in 1, I got positive 2. When I plugged in 1, I got -2. Okay? So 2 answers so far, but I've only used one of my x's. So let's plug in my other, I plugged in one of my y's. Let's plug in the another y. I'm going to come over here. 2x squared minus 3 times -1 squared minus 5 equals 0. -1 squared is positive 1 times -3 is still -3. I kind of see some similar work coming here. Add 8, divide by 2, take the square root. Once again, I get my plus or minus 2. But that was when I plugged in -1, I got a positive 2, and -1, I got a -2. So I end up with 4 solutions on this one, okay? And shame on me. Let's try this one more time. Put my x's and y's backwards. Okay, let's try this again. When I plugged in positive 1 for y, I got a positive 2, and when I plugged in positive 1 for y, I got a -2. There we go. When I plugged in -1 for y, I got a positive 2, and when I plugged in -1 for y, I got a -2. All right, sorry about that. I flip-flopped my ordered pairs since I'm so used to solving for x first. Okay. Hopefully I didn't confuse you there. I just wrote my ordered pairs backwards. All right, let's try a couple more of these. To be honest, you just basically need to think algebraically what we do. If you can't visualize it, that's okay. My first one up there on this one, the top one up there is a circle. Okay, the second one here, an x squared but a y, that's a parabola. Okay, or a quadratic. So when I think about these, you know, what are my solutions? I could cross twice. I could cross, depending on my graph, 4 times, right? I could I could touch like exactly on the bottom here, so I could do 3 times. It's not liking me at all here. I'm too close to the edge. I could touch once, right? I mean, technically, I could just not touch at all or something, right? So there's, again, multiple ways we could do this. I think probably the most is 4 that we could get into that, okay? All right, so let's check it algebraically and see what happens. You know what? I see an x squared to start both of them. A little bit funny, but I think we could just subtract these two. I think they're kind of lined up. So x squared minus x squared would disappear. Then on top I have y minus 2 squared minus a negative 2y, so that'd be plus 2y equals, and then 4 minus 0 is 4. Okay, so that joined my two equations. I'm going to need to FOIL out that y minus 2 squared, so I'm going to get y squared. Two middle terms of negative 2y will make negative 4y. Negative 2 and negative 2 will make positive 4. Plus 2y equals 4. Okay. Y squared, join my y's, I get negative 2y. Subtract 4, and I'm going to get 0. Okay. So it doesn't matter which way I try to take that 4, it cancels out. Quadratic, I can GCF factor that. I can get y and y minus 2. That means y equals 0. Or y minus 2 equals 0, which makes y equal 2. So I get 2 answers for my y's, so I'm going to plug them in. I'm going to choose the bottom equation, x squared minus 2 times my y of 0 equals 0. So x squared minus 0 equals 0, x squared equals 0. Take the square root, and there's a 1 and only 0. There's no plus or minus. So that's one of them. So when x was 0, y was 0. All right, plugging in the 2. X squared minus 2 times 2 equals 0. X squared minus 4 equals 0. X squared equals 4. Take the square root, and x equals plus or minus 2. Okay, so x was 2 when y was 2, or x was negative 2 when y was 2. So in this case, I get 3 answers, okay? So it must be something like this one up here, where it crossed 3 times. All right. Last example here today is a story problem. Find the length and width of a rectangle whose perimeter is 40 feet and whose area is 96 square feet. Okay, think about your equations for rectangles. Okay, so quick reminder, perimeter is 2L plus 2W. Area of a rectangle is length times width. Okay, so if my perimeter is 40 feet, so I can put 40 in here. And my area is 96 square feet. I put 96 in there. I have two equations. They have two variables, so I do have a system. So I kind of need to decide, how do I want to do this? Substitution, elimination, what do I want to do? One thing I really need to be mindful of is I do have multiplication in one and I have addition in the other. And that's something to watch for, okay? I think it might be easier to do substitution, and I'm going to try to take this top equation and get one of my L's or W by itself. So the first thing I'm going to do, just kind of because I can, right? I'm going to multiply this whole equation by half. That'll give me 20 equals L plus W, right, when I distribute that to everything. Remember, you're allowed to multiply by anything you want as long as the whole equation gets multiplied by it. So now I'm going to say L is going to be 20 minus W. Okay. So 96 equals, instead of L, I'm going to do 20 minus W times W. All right, distribute through. 20W minus W squared. I'm going to move everything to the left so my W squared is positive. So W squared minus 20W plus 96 equals 0. Factors of 96 that add to make 20. Is there such a thing? 12 and 8, that'll work. Both get a minus, so we get W minus 12 equals 0, or W minus 8 equals 0. So my width could be 12, or my width could be 8. Okay, so when my width is 12, plug it back in here, 20 minus 12, my length is going to be 8. When my length is 8, 20 minus 8 equals L, then my length is going to be 12. Okay, so there's my choices. If my width equals 12 feet, my length equals 8 feet. And if my width equals 8 feet, my length equals 12 feet. Okay. please show your work on these. Please don't make them a guess and check. If I recall, I got a little annoyed one year when somebody did a guess and check all the time, so I made it so that my numbers weren't whole numbers, so it made it harder to guess and check. So heads up on the test or quiz, that could happen. So if you just learn how to show your work, it'll take care of itself, okay? Try not to guess and check, but do the actual work there. All right, so you need to practice these to make sure you feel comfortable solving these equations. Page 774, 3 through 60 by 3s, and let me know if you have any questions.